Hello students, today's topic is limits. Consider a function f of x is equals to x cube. Clearly, as x takes values very near to 0, the value of f of x also approaches to 0, then we say limit x tends to 0, f of x is equals to 0. So it means that x is tending to nearer to 0 but not equals to 0. For example, if we are taking like limit x tends to 2, so it means it is tending near 2, like x is equals to might be 1.999, or we can say 1.99999, and so or we can say 2.001 or 2.0001. So it is nearly 2 equals to this. Now algebra of limits. So the limit of a constant quantity is the constant itself. Like we have sum of limits, like limit x tends to a f of x plus g of x is equals to limit x tends to a f of x plus limit x tends to a g of x. Similarly, difference of two limits is equals to their difference, like limit x tends to a f of x minus g of x is equals to limit x tends to a f of x minus limit x tends to a g of x. Next is like limit x tends to a f of x into g of x is equals to limit x tends to a f of x into limit x tends to a g of x. Like if we have a function limit x tends to a f of x upon g of x is equals to limit x tends to a f of x whole upon limit x tends to a g of x. Now we have some rules that what it should not be. Like it is not of the form, it is not of the form 0 by 0 or infinity by infinity. If this is the function, then we have to choose either a method of factors or method of substitution. Then we have to apply method of factor or method of substitution. Like we can use some formulas as well of this. We have limit x tends to a x raised to power n minus a raised to power n over x minus a is equals to 1. Limit x tends to 0 sine of x over x is equals to 1. And limit x tends to 0 cos of x minus 1 over cos of x is equals to 1. And limit tangent x over x is equals to 1. Limit x tends to 0 limit x tends to 0 tangent of x over x is equals to 1. Limit x tends to 0 1 plus x whole raised to the power 1 by x is equals to e. Limit x tends to 0 e raised to the power x minus 1 over x is equals to 1. Limit x tends to 0 log of with base e 1 plus x over x is equals to 1. and limit x tends to 0, a raised to the power x minus 1 over x is equals to log of a. These are the limits including exponential and logarithmic functions. So we can use this method, these formulas directly to solve our questions. We can apply by multiplying or dividing, or directly we can as per the given question. We have one or two trigonometric functions. Limit x tends to 0, sine of x is equals to 0. Limit x tends to 0, cos of x is equals to 1. We can this as a sandwich theorem. Also we can say this as a sandwich theorem. Now how we can apply this? We have an exercise of NCERT book. First exercise of limits. We have given limit x tends to 3 and function is x plus 3. We have to evaluate. To put x is equals to 3 in the given function, so 3 plus 3 is equals to 6 is the answer. Like we have one more question, limit x tends to pi x minus 22 by 7. So we are putting pi minus 22 by 7. No need to put the value of pi. Like we have one more limit x tends to r tends to 1 pi r square. So in place of r we have to put 1. 1 square is 1. So answer is pi. Like we have one more question. Limit x tends to 2, 3x square minus x minus 10 over x square minus 4. As we can see, if we are putting the limit 3 into 2 square minus 2 minus 10 over 2 square minus 4, we got 2 square is 4, 4 is a 12 minus 12 over 4 minus 4. So this is a 0 by 0 form. So in this case, we have to factorize our given function. So that is limit x tends to 2, 3x square minus x minus 10. We can split this by splitting the middle term. So we got the factor as x minus 2 into 3x plus 5, and in denominator we can apply a square minus b square, that is x minus 2 into x plus 2. So x minus 2 cancels x minus 2. Now as we can say, the factor that is making this function as 0 is cancelled out. Now we can put the value of limit, that means x is equals to 2. So 3 into 2 plus 5 over 2 plus 2. So 6 plus 5 over 4. So 11 by 4 is the answer of this limit. We have one more question. This limit x tends to 3, x raised to the power 4 minus 81 over 2x square minus 5x minus 3. So here as we can also see, 3 raised to the power 4 minus 81, 2 into 3 square minus 5 into 3 minus 3. If we are going to be evaluate this is again gives you 0 by 0 form. So in this case also we need to be factorize the function. In the numerator we can apply a square minus b square. So we got x square minus 9 into x square plus 9, and in the denominator we have to splitting the by middle term splitting. So x minus 3 into 2x plus 1. Now again we can apply a square minus b square in the numerator. So it becomes x minus 3 into x plus 3, and this remains same, x square plus 9. In denominator it is x minus 3 into 2x plus 1. So x minus 3 cancelled out. As we can see, that factor which is making this function as 0 is cancelled out. Now we can put the value of limit, that is x is equals to 3. So 3 plus 3 into 3 square plus 9 over 2 into 3 plus 1. So 6 into 18 over 7. So it is 108 by 7. Now we have a function, next question of limit x tends to minus 2x 1 by x plus 1 by 2 over x plus 2. So if we apply here also putting the value of limits of 1 minus 1 by 2, 1 by 2 minus 2 plus 2, this also gives you 0 by 0 form. So in this case we have to factor it or either taking the LCM. So while we are taking the LCM, so LCM becomes 2x. It is 2 plus x over x plus 2 or 2 plus x. The numerator cancels numerator. We remain with limit x tends to minus 2, 1 by 2x. Now putting the value of limit, so 1 by 2 into minus 2 is equals to 1 by minus 4 is the answer of this. Now we have next one, limit x tends to 0 sine of ax over bx. As we studied the formula, limit x tends to 0 sine of x by x is equals to 1. So we have to apply this formula here. So how we can apply this? Because here theta is as ax and in denominator we have bx. So making the same theta, we can multiply and divide by a so that it becomes the same. So b into ax into a. So a by b is a constant value. We can write it outside the limit. Now remain with sine of ax by the formula. This limit is equals to 1. So a by b into 1 is equals to a by b. This is the answer for this function. Now we have another question. Limit x tends to 0 cos of 2x minus 1 over cos of x minus 1. So again, if we are putting the limit, this becomes 0 by 0 form. So for that, we are applying the formula of 1 minus cos 2x, that is 2 sine square x. So here it is cos 2x minus 1. So we can write minus 2 sine square x over minus 2 sine square x by 2. This is half angle formula. Now minus 2 cancels minus 2. So limit x tends to 0. We need sine x by x. So we are multiplying and divide by x, and similarly with the denominator we need x by 2. So multiply and divide with x by 2. And there is a whole square. So this x cancels x. This is numerator by the formula limit x tends to 0 sine of x by x is equals to 1 using this formula. So numerator become 1 by 1 into 1 by 2 whole square. Now reciprocating it, we got 4 as our answer. Like we have one more, limit x tends to 0 x secant x. So we can write it as x tends to 0 x by cos x. So we can write as limit x tends to 0 into x and limit x tends to 0 1 by cos of x. So this is 0 into 1. So that is 1 answer. 1 into 0 is 0 is the answer. Like we have limit x tends to 0 cosecant x minus cot of x. So applying the formulas of trigonometry, that is cosecant x is 1 by sin x minus cot x is cos x by sin x. Now taking the LCM, so limit x tends to 0, sin x is the limit 1 minus cos x. Now applying the formula, half angle formula, so 1 minus cos x is 2 sin square x by 2 and sin x is 2 sin x by 2 into cos x by 2. 2 cancels 2, 1 power of sin x by 2 cancels sin, so limit x tends to 0, sin by cos is tangent x by 2. Now tangent x by 2, we need x by 2 more to make it the formula. So limit x tends to 0 tangent x by 2 upon x by 2 into x by 2. So as by the formula limit x tends to 0 tangent x by x is equals to 1. So we are using it and putting the value of limit. So 1 into 0 is equals to 0 is the answer. Now we have one more question. Limit x tends to 0 f of x and limit x tends to 1 f of x, where f of x is defined by 2x plus 3 if x is less than equals to 0 and 3 into x plus 1 if x is greater than 0. So in this case we have to take for limit x tends to 0 f of x. So we have to take left hand limit and right hand limit. In left hand limit, limit x tends to 0 negative, that means less than 0. So in less than 0 we have a function 2x plus 3. So putting x is equals to 0 minus h, so h tends to 0. So limit h tends to 0, 2 into 0 minus h plus 3. So putting value of limit, so 2 into 0 minus 0 plus 3, we got 3. In right hand limit, limit x tends to 0 positive f of x, that means greater than 0. So we have the function 3 into x plus 1. Now putting the value of limit 3 into 0 plus 1, so it is 3. So right hand limit is equals to left hand limit is equals to right hand limit. Hence limit x tends to 0 f of x exists and is equal to 3. Whenever we have a different function for the different limit, we have to check it for left hand limit and right hand limit by applying the sign of negative on the given limit. Now for limit x tends to 1 f of x. So again we have to take left hand limit. Left hand limit is equals to limit x tends to 1 negative, that means less than 1. So for less than 1 we have a function 3 into x plus 1. Again substituting, put x is equals to 1 minus h when h tends to 0. So limit h tends to 0, 3 into 1 minus h plus 1. So it is equals to limit h tends to 0, 3 into 2 minus h, putting the value of limit, that is 0. So 3 into 2 minus 0 is equals to 6. Now right hand limit is equals to limit x tends to 1 positive, that means greater than 1. This is also 3 into x plus 1. Now again put x is equals to 1 plus h, so that h tends to 0. So limit h tends to 0, 3 into 1 plus h plus 1 is equals to limit h tends to 0, 3 into 2 plus h. So h is 0, putting the value of limit 3 into 2 plus 0 is equals to 6. So here also left hand limit is equals to right hand limit and is equals to 6. So limit exists and this is equals to the 6. So in this way we can do if the different function is given. Now we have next exercise 13.2, in which evaluate limit x tends to 0 e raised to the power 4x minus 1 over x. So according to the formula, we have a formula like limit x tends to 0 e raised to the power x minus 1 over x is equals to 1. This is a formula. For using this we need 4. So for that we should multiply numerator and denominator by 4 so that we can get 4x to make it according to the formula. So 4 into limit x tends to 0 e raised to the power 4x minus 1 over 4x, putting the limit, so this is 4 into 1 is equals to 4 answer. Now next question is limit x tends to 0 e raised to the power 2 plus x minus e square over x. So similarly we have to make it a formula, this one. So we are using exponential formula, separating e raised to the power 2 into e raised to the power x minus e square over x. Now taking e square common, so we remain with e की power x minus 1 over x. So this complete becomes 1. So e square into 1 is equals to the e square is the answer. We have a one more question. Limit x tends to the 5 e raised to the power x minus e raised to the power 5 over x minus 5. So as we can see, here limit is tending to 5, not to the 0. For the formula, it should be tending to 0. So for that purpose, we will put x is equals to 5 plus h. So as x tends to 5, so h tends to 0. So limit h tends to 0, e raised to the power 5 plus h minus e raised to the power 5 over 5 plus h minus 5. So limit h tends to 0, taking e raised to the power 5 common, so it becomes e raised to the power h minus 1 over h. So this part becomes 1. So e raised to the power 5 into 1 is equals to e raised to the power 5 is the solution for this answer. Now we have one more question. Limit x tends to 0, log with base e 1 plus 2x whole upon x. So again we are applying the formula. So for that we must have in denominator 2x because in numerator it is 2x. So for that we are multiplying numerator and denominator by 2. So limit x tends to 0 log with base e 1 plus 2x over 2x into 2. So this becomes 1. So 1 into 2 is equals to 2 is the answer. Now we have next exercise based upon derivatives. First principle, derivative from first principle. So first principle says that limit h tends to 0 f of x plus h minus f of x over h. So whatever function is given, we have to replace it by x plus h and putting in this formula, then evaluate. So we have given a question x square minus 2 at x is equals to 10. So we consider f of x is equals to x square minus 2. Now we have to find f dash 10 because it is x is equals to 10. So as per formula, limit h tends to 0. So x square is replaced by 10 plus h because x is 10. 10 plus h square minus f of 10 over h. So f of 10, that means we need to be put the value here as 10. So limit h tends to 0, 10 plus h ka whole square is 100 plus h square plus 20h. We are applying the identity of a plus b whole square minus f of 10 is 10 square minus 2 whole upon h. So limit h tends to 0, 100 plus h square minus 20h minus 100 plus 2 over h. 100 cancelled out. We remain with h square minus 20h plus 2. Here we also have minus 2. 10 plus h whole square minus 2. So this is minus 2 plus 2 cancelled out. Now taking h common, limit h tends to 0, h common h minus 20 upon h. This h cancelled out, putting up the limit. So 0 minus 20 is equals to minus 20 is the answer. Next is find the derivative of 99x at x is equals to 100. So it means we have f of x is equals to 99x. So f dash 100 is equals to limit h tends to 0 f of 100 plus h minus f of 100 upon h. So limit h tends to 0, 99 into 100 plus h minus 99 into 100 upon h. So limit h tends to 0, we remain 9900 plus 99h minus 9900 over h. So 9900 cancel out this, h cancel this, we remain with 99, that is the answer. Like we have another question. Find the derivative of the using following function using first principle. So we have f of x as x cube minus 27. So f dash x is equals to limit h tends to 0 f of x plus h minus f of x upon h. So it means x plus h का whole cube minus 27 minus x cube minus 27 whole upon h. Opening the cube, limit h tends to 0. So it becomes a cube plus b cube plus 3a square b plus 3ab square minus 27 minus x cube plus 27 whole upon h. So minus x cube plus x cube cancelled out, plus 27 minus 27 cancelled out. Now we are taking common h. So limit h tends to 0, taking h common, remain with h square plus 3x square plus 3xh whole upon h. H cancel. Now putting up the limit, so 0 square plus 3x square plus 3x square into 3x into 0 का square. So we remain with 3x square plus 3x. This is the answer. Into 0, so 3x square is the answer. Now we have another question. We have given f of x is equals to x raised to the power 100 over 100 plus x raised to the power 99 over 99 plus and so on up to x square by 2 plus x plus 1. We have to prove f dash 1 is equals to 100 into f dash 0. So f dash means we need to find the derivative of this function. So finding the derivative, so f dash x is equals to d by dx of all these functions. So it 100 into x raised to the power 99 over 100 plus 99 into x raised to the power 98 upon 99 plus and so on plus 2x upon 2 plus x का 1 plus 1 का 0. Now these values are cancelled out. We remain with x raised to the power 99 plus x raised to the power 98 plus and so on plus x plus 1. Now we have to verify f dash 1. So we are finding f dash 1 is equals to 1 raised to the power 99 plus x raised to 1 raised to the power 98 plus and so on plus 1 plus 1. So 1 plus 1 plus and so up to 100 times. So we get as 100. This is up to 100 times. Now 100 into f dash 0. That means in place of x now we have to put in derivative 0. So 0 raised to the power 99 plus 0 raised to the power 98 plus and so on plus 0 plus 1. So 0 up to 99 times, then plus 1 is 1. And 1 multiplied with 100 is gives you 100. So that means left hand side is equals to right hand side. Hence proved. Now we have one more question. This is x raised to the power n plus ax raised to the power n minus 1 plus a square x raised to the power n minus 2 plus and so on plus a raised to the power n minus 1x plus a raised to the power n. We need to find derivative of this. So consider this as f of x, derivating both sides with respect to the x. So it becomes f dash x is equals to n into x raised to the power n minus 1 plus a into n minus 1 into x raised to the power n minus 2, because we are subtracting 1 from each power, so n minus 1 becomes n minus 2. Similarly, a square into n minus 2 x raised to the power n minus 3 plus and so on a raised to the power n minus 1, and this become x raised to the power 0 1, so plus, and then a raised to the power n is 0 because there is no x variable out there. So a raised to the power n is considered to be a constant function and derivative of a constant function is 0. Now solving all these values, so we remain with n x raised to the power n minus 1 plus a into x n minus 1 x raised to the power n minus 2 plus a square n minus 2 into x raised to the power n minus 3 plus and so on plus a raised to the power n minus 1. This is the required solution. Now we have next question based upon U into V rule, or we can say product rule. So in product rule, what we have to do, taking first function as U and second function as U. So if y is equals to uv, so derivative of y becomes dy by dx, and u remains the same. We need to be derivative of second function plus second function as it is derivative of first function. This is called the product rule, and this we going to be used in the our next question, that is y is equals to x minus a into x minus b. So derivating both side, differentiating both side with respect to x, so it becomes dy by dx. Consider x minus a is u and this as v. So x minus a as it is, d by dx of yani ki derivative of x minus b plus x minus b as it is and derivative of x minus a, that means first function. Now derivating, so x minus a as it is, x is 1 and b is 0 because b is constant here. Now x minus b, x is 1 and a is 0. Similarly, a is 0 here. So it is x minus a plus x minus b. We can add them. So it is 2x minus a minus b is the answer of this function. Now we have one more formula of u by v, or we can say quotient rule. So in this, what we need to do, square of denominator function as it is, derivative of numerator function minus numerator function as it is, and derivative of denominator function. So based upon this, we have a function x minus a over x minus b, derivating both sides with respect to x. So dy by dx is equals to x minus b whole square, x minus b as it is, d by dx of x minus a minus of x minus a as it is, d by dx of x minus b. So it is x minus b into 1 minus 0 minus x minus a as it is into 1 minus 0, because a and b is to be considered as a constant function. So it is x minus b minus x plus a upon x minus b ka whole square, x cancelled x, so we remain with a minus b over x minus b ka whole square. This is the solution for this particular question. Now we have some more questions. We can do their derivatives directly, like we have y is equals to 2x minus 3 by 4. So dy by dx is equals to d by dx of 2x minus 3 by 4. So 2x is 2 because x का 1 हो गया, and minus 0 because constant function का derivative होता है 0. So 2 is the answer of this function. Like we have our next function y is equals to 5x cube plus 3x minus 1 into x minus 1. Here we can apply the product rule, or either we can product the function first then find the derivative. In both the ways we can get the same answer. So here we are using product rule, that means u into v. First consider u, second is v. So differentiating both sides with respect to x, so dy by dx is equals to 5x cube plus 3x minus 1 as it is, derivative of second function, that means x minus 1 plus x minus 1 as it is, derivative of second function, that means I have 5x cube plus 3x minus 1. So 5x cube plus 3x minus 1 into x का 1 minus 0 plus x minus 1 as it is into 15x square plus 3, because power से multiply करेंगे तो 5 is 15 and subtracting 1 from the power, so 3 minus 1 remains 2. So we remain with 5x cube plus 3x minus 1 plus x, and product, we'll do product of this, so we'll remain with 15x cube plus 3x minus 15x square minus 3. Now solving 5x cube plus 15x cube is 20x cube, plus 3x is plus 6x, minus 15x cube, minus 1 minus 3 is minus 4. This is the answer. So in this way we can do the derivative. Now we have some formulas for the trigonometric functions, like d by dx of sin x is equals to cos x, d by dx of cos x is equals to minus sin x, d by dx of secant x is equals to secant x into tangent x, d by dx of cosecant x is equals to minus cosecant x into cot x, d by dx of cot x, d by dx of cot x is equals to minus cosecant square x, and d by dx of tangent x is equals to secant square x. Thanks for watching. Like it, subscribe it.